Hello, so I've been told that rectangle ABCD, so ABCD, this rectangle here, is mathematically similar to rectangle DAEF, so DAEF, that rectangle there. I've also been told that AB is equal to 10 centimetres, so there's my 10 centimetre side, and AD is 4 centimetres. This little, the vertical side along here is 4 centimetres. And I've been asked to work out the area of DAEF, so in other words, that little baby rectangle in there. Okay, essentially what this question is asking is, do you understand what it means if two shapes are mathematically similar? So let's just do a quick reminder. Let's suppose we have a little baby rectangle, little baby triangle down here, sorry. So we fill in the angles. Let's suppose this angle's 90, this angle's 30, and this angle's 60. And let's put some sides on. So let's make this base 4, let's make this vertical height 3, and let's make the hypotenuse 5. Okay. And all it means to be mathematically similar is that they share the same DNA, so in other words, the angles are the same, but it's just the sides which are different, but the sides are different in the same proportion. Let me show you. So let's suppose we have a bigger version of this triangle. So we've got 90, 60, and 30 again. The angles remain the same. It's just the side lengths which change. So let's make this base now. Let's make this base 20. Okay. Let's make this vertical height 15. Okay, and let's make this hypotenuse 25. Okay, now all it means is that the side lengths, the difference between this triangle and this triangle here, so the connection, if you like, is that they share the same scale factor. So this bigger triangle is just some scale factor times the little triangle. Okay, so it means as well the side lengths will also change by this scale factor. So let's just verify that. So let's suppose we have the base. So we have the base of the big triangle is 20. That should be equal to something times the base on the baby triangle. So the baby triangle length base is 4. Okay, so what times 4 gives me 20? What times 4 gives me 20? That's 5, right? So 5 times 4 gives me 20. Then let's look at the vertical height. So the vertical height on the big triangle is 15. Okay, the vertical height on the baby triangle is 3. Okay, so what times 15... what times 3 gives me 15? It's 5 times 3 gives me 15. And let's just verify. Let's do the hypotenuse as well. So the hypotenuse on the big triangle is 25. Okay, the hypotenuse on the baby triangle is 5. So what times 5 gives me 25? It's just 5. Okay, so look what's in common. It's 5 which is in common. So therefore my scale factor must be 5. So if you have a look back up at my question then, all this means, if these two rectangles are mathematically similar, it just means that my baby rectangle, so this baby rectangle is A, E, F, and D, is mathematically similar. It means that it's, if I just multiply by some scale factor, I should get my big rectangle. So my big rectangle looks like this. So my big rectangle, which is A, B, C, D. So let's just put the side lengths back on. So I know that this side length here, is 4 centimetres. Okay, I know that this side length here is 10 centimetres. Okay, and I may as well fill the opposite sides as well. So this is 10 centimetres and this is 4 centimetres. Okay, and I also know that this side length here is 4 centimetres, which means that this side length here is also 4 centimetres. Okay, so if they're mathematically similar, all it means is this rectangle here, if I multiply it by some scale factor, I will get this rectangle here. Now, at the moment, it doesn't really look like the triangles example which I had up here. Okay, it's not necessarily that obvious. But if I rotate this rectangle by 90 degrees clockwise, it should hopefully become clear. So if I rotate it by 90 degrees clockwise, I'll end up with this. So now, hopefully, you can see that this rectangle is clearly just a shrinked down version of this rectangle, or this rectangle is a blown up version of the small baby rectangle. So in order to work out the area of my baby rectangle, what do I need? Well, I need this side here, because this side, the DF, times this side here will give me my area. So what is DF? Okay. Well, if you remember, back in my triangle example, I said that the sides should change by the same scale factor. So in other words, this space here is 4. When I multiply it by some scale factor, I should get back my big base. So in other words, my 10. And likewise, if I look at the vertical heights, if I have this baby this baby height. So this baby height at the moment is just df. I don't know what that value is. That's what I want to find out. When I multiply it by some scale factor, so the same scale factor, I should get back my big height. So my big height was 4. So in other words, that should be equal to 4. That's fine. That's just a set of simultaneous equations, which I can totally solve. So if I just try and solve and get SF on its own, so if I just try and get SF on its own, then I can just try and solve DF. So if I rearrange my first equation, let's number it. So this is equation 1, this is equation 2. So if I rearrange my first equation to get SF on its own, are you happy that at the moment I've got 4 times SF? So if I divide by it 4, then I should have just SF is equal to 10 divided by my 4. Okay, and likewise I can rearrange equation 2. I can rearrange equation 2 to say, well, at the moment I've got SF times DF. So if I just want SF on its own, then I just make it DF times smaller. So I just say, well, SF then is just equal to 4 divided by DF. Okay, I've just divided by 4 in the first equation, and I've just divided by DF in the second equation. Okay, so now look what this is saying. I'm saying, well, SF, my scale factor, is 10 over 4, and I'm also saying my scale factor is 4 over DF. So are you happy then that that thing is the same as that thing? So I could just write them as equals. So now it's just a case of solving for DF. So I just want DF equals something. Okay, so how am I going to do that? Well, first of all, I've got a DF on the denominator. So it makes sense then just to multiply both sides by DF, surely. So if I make this over here. So if I multiply both sides by DF, so I multiply this by DF, and I multiply DF over here. Okay, then are you happy then on the right hand side, this DF cancels with this DF, so I'm just left with DF times 10 over 4 equals 4. Okay, I can now work with this, because if I multiply by 4, if I multiply both sides by 4, so if I multiply this side by 4, and if I multiply this side by 4, you're happy that on the right hand side my 4's just cancel, okay, and I'm just left with 4 times 4. Well, 4 times 4 is just 16 on the right hand side. Okay, but look at this. I've got DF times 10 equals 16. I'm just after DF on its own. So if DF at the moment is times 10 two's big, then I'm going to have to divide through. I'm going to have to divide by 10, and I'm also going to have to divide by 10 on this side. So in other words, I've got 10 over 10 here. Okay, and I've got 16 divided by 10. Well, 16 divided by 10 is just 1.6. So in other words, I can now say that DF is just equal to 1.6. So DF is equal to 1.6. Is that the end of the question? No. I need to find the area of that rectangle. Working out the area of this rectangle here is dead easy. I just do this DF side times by my 4, and that should give me my answer. So my DF is 16, so therefore my area will be equal to that times 4, okay? Because I'm just multiplying this side here by this side here, which of course is just DF times 4. So I've got 1.6 times 4. So what's that? Well, when I multiply by 4, all I've got to do is double it and double it again, because 4 is really 2 times 2. So what's 1.6 times 2? Well, 16 times 2 is equal to 32. But 16 is 10 times 2 big. So in order to get back to 1.6, I'm just going to have to divide by 10. So I'm going to have to divide 10 both sides. So what's 32 divided by 2? I end up with 3.2. Okay, now what's 3.2 times 2? So that's halfway there. I've times by 2, so I've now got 3.2. But then I'm going to have to do 3.2 times 2. So 3.2 times 2, well, 32 times 2 is equal to 64. 32 times 2 is equal to 64. So 64 is just 10 times 2 big, because I've multiplied by 10 here, which means that in order to get rid of that times 10, I'm going to have to divide both sides by 10. So in other words, that then takes me back to 6.4, because 64 divided by 10 is 6.4. So there's my area, 6.4 centimetres squared.